Hi, everyone. This is your host, Matt McMahon, in Inventing a Free World. Our guest today is Peter Lindemann, and so I guess Aaron, I can't pronounce his name. Murakami. He saw what we were doing with the show, and he's pretty well connected with a lot of what some people would consider the really high up there guys that are doing alternative energy. And so Aaron is going to be trying to help us get a lot of really smart, amazing guys information to the show, which also allows people to get involved and ask the questions that they never got to ask another inventor. So, sorry. Sorry, I'm bombing here a little bit. Oh my God, there's... All right, so this week we have Peter Lindemann, and he's done some work on the desulfating of batteries, and I'm sure if I've made any rejuvenating batteries. So I was going to say a speech, but unfortunately I am on my Bluetooth and trying to drive to a safe location, so I'll save it for a little bit. If anybody is listening on the website, please go to, but first before you go to it, click the mute button and go down to the bottom right-hand corner and click on the Skype. As soon as you click on it, hit the mute button so that way there's no interference. So I'd like to welcome Peter Lindemann to the show. Hi, Peter. How's it going?
Really well, Matt. Thanks for inviting me on the show.
No problem. I really appreciate you joining. So this battery rejuvenation stuff, what's, a lot of people that are involved in the Bedini technology, they know a little bit about that. Is that what this is, or is this something a little bit different?
Well, it grew out of that situation. John started building regenerative motors back in the 1970s, and instead of just taking the energy that you can get back out of a coil when you turn the power off and putting that on a capacitor and trying to use it again, typically in a situation like the motors that he has, the amount of electricity you can get back out of that situation looks like maybe 30 or 35% if you meter it. So it doesn't look that exciting, especially to people. Yeah.
That leads to a really big question that a lot of people have had about like the SSG circuit. A lot of people on YouTube are, they'll put with their video free energy Bedini motor. So what is the consumption, and what is the equivalency of what you're getting out of it? Is there a 30% loss? Is there a 30% gain? And this is just with the regular, little wheel, nothing too advanced.
Right. Well, that's what I was kind of going to get to. If you just meter it with standard meters, in other words, expect everything to be referenced to ground and all the standard electrical engineering protocols, it looks like you can recover maybe about 35% of the electricity. And so the naysayers and the doubters have had a field day with this, and we've never really debated those issues. What John found out early on is if you take that amount of energy, whatever it is, metered at 30, apparently looking like 35% of what you're taking out of the front battery, and you just put that on a second battery to charge it, instead of trying to put it on a capacitor or burn it in a light bulb or do something else with it. If you just shunt it off to a second battery. A remarkable transformation happens whereby the back battery charges up to maybe 90 to 95% of what the front battery ran down from, which makes the energy look a lot more interesting coming out of this thing. And when I came to work for him in 2004, this is pretty much, he'd been doing these types of things and trying to convince people that it was interesting and, getting a lot of pushback from electrical engineers who just wouldn't, who'd measure the output directly and say, there's not enough here to push a fly up the wall, and you aren't going to get us to look at it any further. And so we started, and so we started doing, some very systematic experiments where we started looking at this and started looking at what was going on in the batteries and started really studying about what goes on in the battery during the charge and during the discharge and the whole all the chemical reactions that were going on.
Wow.
How the battery was changing under the influence of this energy coming back out of the machine.
Now, would you be willing to explain some of that? Is that proprietary knowledge at this point, or are you able to share that information?
Well, I mean, we have shared quite a bit of it in lectures and in training situations. We have a series of lectures that I've given at conferences. One of them is called Battery Secrets, where I talk about what goes on in the battery, and then another one that I gave recently at a conference this summer called Battery Rejuvenation, where we go rather deeply into all of these things, but it's kind of an arcane subject, and I don't want to, either bore or your audience or talk over them from a technical point of view, but I can certainly go over the fundamentals of it.
Well, see, the way how this sort of works is that if people who are very advanced thinkers, or that are well involved in their technology, they usually have a hard time explaining that to the public because not everybody understands it. So my job is sort of to ask you the questions where when you say something, if I sort of think, or if someone writes in the message board, what did you mean? We'll ask you to elaborate on that a little bit more, or I'll ask a specific question so that way it is more understandable.
Sure.
Personally, I'm very interested to know what is happening to the chemicals within the battery. I have my own theories. I haven't seen your what do you call it, conferences, but I would definitely like to know, and I'm sure there are people listening to the show. I know that there's friends of mine that are on here that have experimented with Bedini technology. So, I would really like to hear that.
Great. I can go through it. I can. So basically, every battery chemistry is different. But we focus primarily...
Like individually? Do you mean individually or the different types?
No, I mean the different chemistries. In other words, a nickel-cadmium battery is chemically different a nickel-metal hydride battery, or a lithium battery, or a lead-acid battery, and so on. So we have focused primarily on lead-acid batteries because they're still the workhorse of the world in relationship to large-scale electric power. And... an interesting detail is that there are actually more lead-acid batteries on the planet than human beings, so there's over 8 billion lead-acid batteries on the planet. Most of us own, 7 or 8 of them.
I own about 10.
Yeah, they're in our cars. They're all over the place. They're used to start our lawnmowers and all kinds of things. They're everywhere. So, and of course we want to keep lead out of the landfills, and we want to make sure that this material is, handled properly environmentally. And so we have focused primarily on the lead-acid battery as the one place, if we really understand the lead-acid battery and can use it properly and keep people from needing to buy new ones and keep them from wanting to throw them away, then we feel like we've made a significant contribution to a cleaner, greener world. So
reusing.
We're reusing and lengthening the useful life of, the batteries. So, so with that in mind, I can talk to you about the lead-acid battery in particular, and just so that everybody knows that there are variations, on these themes that relate to the various other chemistries, but that the information that I'm going to tell you is specific to lead-acid batteries and would have to be modified to directly relate to another type.
Okay.
So now that we're a little oriented here, believe it or not, a lead-acid battery is a fully reversible chemical water fuel cell.
And I'm aware of that.
What I mean by that is, because most people don't know that.
No, they don't.
When you take electricity out of the battery goes through a series of chemical changes whereby it makes a water molecule. And that is a very interesting situation. So when you take electricity out of a lead-acid battery, it's making a water molecule, and it is the production of that water molecule that actually releases the electricity for you to use. And so the discharge process is very straightforward. There's only one significant electrochemical pathway, and that is when you take electricity out, the battery makes water, and that causes two other things to happen. One is that the amount of acid in the battery starts getting watered down in the electrolyte. So we're making the electrical properties of the liquid in there less electrically conductive. And the other thing is that the salt, or in this case the acid, which is sulfuric acid, and its chemical formula is H2SO4, or two hydrogen atoms connected to a sulfate ion, one sulfur atom and 4 oxygen atoms, SO4. So the process takes the hydrogen, combines it with some oxygen on the positive plate of the battery, which is made out of lead oxide, makes that water molecule, and then it's got these sulfate ions that has to happen, that has to go somewhere, and they plate out on both the positive and negative plate. So there's two things that are happening. The electrolyte is getting more dilute, and the sulfate material is being plated out on both the positive and the negative plate of the battery. And that's the normal discharge process, and that's the only thing that can happen. So discharge is never a problem. You can ask the battery to discharge, and that's what happens. Okay? So all the problems associated with battery degradation and the ability of the battery to continue to do this process has to do with the efficiency and the effectiveness of the charging process. Because when you put the electricity back into the battery, the first thing you have to do is you have to break up those water molecules, and that's generally called electrolysis. So when you put electricity in, it breaks the water into hydrogen and oxygen. And everybody is familiar with that process who has any chemical background. It's a very basic process.
Yeah.
However, if that's all that happens, that doesn't charge the battery. In other words, if I just put electricity into water and it makes hydrogen and oxygen, and the hydrogen and oxygen just bubble out, then I've produced hydrogen and oxygen gas, but I certainly haven't done anything else. And so it is possible to put electricity back into the battery in such a way that does not charge the battery. Now, this is something that most people haven't, who haven't looked into the situation, don't understand. And this gets into, okay, so we're looking at how efficiently the battery is charging. In other words, I'm buying electricity from the wall to charge this battery back, and how much of that electricity am I actually getting back into the chemical changes that I need to have happen in there so that I can pull the electricity out later. And a typical battery charger that you buy for these things is really scary as far as how efficient it is. It's about 35% efficient. In other words,
so it means that there's a 70% waste in energy when you're charging.
Well, let's just say a 70%. Yeah, you can use the word waste. I would just say yes.
Okay.
Yeah. And so when we started looking, when John Bedini and I started looking at this, we just said, well, there's definitely room for improvement here. And so we started looking very carefully at what needed to happen. And what we found is that what needs to happen is that when the electricity is applied to the battery, the electricity has to do two things, not just one. If it just does one thing, it creates electrolysis and the gases bubble off.
Okay.
Okay. But if it does the right thing, if it does what it takes to charge the battery, then a slightly longer, complex set of activities happens, and that is that the electricity is added to the battery, the water molecule is broken into hydrogen and oxygen, and it's the energy in that reaction is then characterized in such a way electrically that the hydrogen, instead of forming hydrogen gas and bubbling out, creates hydrogen plus charge ions which stay in solution, and they go and grab sulfate ions off the plates and stay in solution in the water. Whereas the oxygen, which becomes liberated, goes to the positive plate of the battery and reforms the lead oxide and plates itself back on the positive plate. Now, if all of those things don't happen, then you haven't charged the battery. And so you can see that, well, heck, that's a lot of stuff that's got to happen.
Yeah.
But if you can get all that stuff to happen, then you've actually charged the battery. So so we started looking. John's a master circuit designer, and
electronic engineer.
Electronic engineer and audio engineer. It's very it's famous, no less than famous in the audio industry. But we had noticed for decades. John had noticed for decades that the little pulses of electricity that were coming out of his machines tended to create this very, very, very efficient charging process. In other words, the battery looked like it was charging way better and way faster than the amount of electricity that we were giving it. And so once we realized what it really took to create a charge, then we went back and looked at what was going on with these pulses that were coming out of his machines. And so, we broke this process down in a number of steps. Doing the hard science, and came up with an understanding of what it actually took to not just charge a battery efficiently, but we also started understanding why ordinary battery chargers don't do this particularly well, and that was the fundamental reason why batteries don't last as long as the manufacturer says they should. So, for instance, like a golf cart type of battery, which is a 6-volt, 225 amp hour lead acid battery, the manufacturer says that these batteries can last 5,000 cycles. And I'm sure you can go to every single golf course, golf cart barn, and the guy maintaining these things is going to say, well, I'm lucky to get 2 to 3 years out of these batteries, and we're charging and discharging them about once a day. So once a day for a year is about 360 cycles. So 3 years is just a little over 1,000 cycles, and by then the battery's shot, won't charge. They take it out and they can barely get 9 holes, much less 36, and the battery's lost all its capacity. So even though the battery manufacturer says it can last a lot longer than that, out in the field, it just doesn't. And so John and I started looking at that and saying, okay, what's going on? Why are the batteries not living up to their potential life cycle rating? And so we started looking at making chargers that would solve these issues. First of all, chargers that would lengthen the life cycle operation. And then that led also to an understanding of what kind of damage was going on in the battery that shortened its life, and then what we needed to do to even a damaged battery to bring it back to the chemical state of what we call a like-new battery. In other words, if I can take a battery in any condition and put it through a series of processes, and at the end of that process I have a battery where the negative plate is 100% lead, and the positive plate is 100% lead oxide, and all of the sulfate ions are in the electrolyte, then I don't care how old the case is, and I don't care how many times you've charged and discharged it in the past, that battery is, for all intents and purposes, chemically, it's brand new. It's exactly the state at which it came out of the factory in the first place. And
so could you take a battery that says some, like here in Canada it's cold, so batteries don't like our climate, so they bulge out a lot. That's usually what kills a battery. Could you take one of those batteries and still bring it back to new?
Oh yeah, John's taken batteries that were set out in the in a field, and they froze solid in the winter and all kinds of things, and brought them back to 100%.
Okay.
Yeah.
Okay, because that's something that a lot of researchers think that you can't do. If you have a damaged battery, you're better off to start with just one that can't hold the charge.
Well, in some cases that's true, but it depends on what the damage is. In other words, if you've got a battery that has cracked terminals, where the plates are cracked and no longer electrically conductive across the entire plate because of physical damage, things like that, then yes, that battery needs to be recycled. But if the cells aren't shorted out and the plates are still functional, if they've never poured the acid out, and tried to rejuvenate it with some other chemicals. If if the battery has basically just been sitting for a long time or been cycled repeatedly and charged back with a standard charger, then usually these types of batteries can be rejuvenated or brought back to what we call like new condition.
Okay, that's awesome. So the batteries, you were saying the lead oxide. Typically, in a battery, is that what the plates are? They're lead and then the lead oxide plate.
Yeah. The positive plate is lead oxide, and actually, it's that chemical difference between the plates is what actually creates the voltage difference in the electrical system.
Okay. So much like how people make earth batteries, then.
Exactly. In other words, if I just pound a piece of steel into the ground and a piece of copper, the voltage potential difference between those two metals in the same situation is a little over a volt. Well, in sulfuric acid, the voltage potential difference between lead oxide and lead is about 2 volts. And so 6 of those things connected in series gives you the 12-volt battery. So,
Okay. So
you are saying that they can actually increase the capacity of the batteries. And yes, we've seen that too. We're usually very conservative about what we claim. We like to underclaim and overdeliver. But
well, then you don't have to deal with control attacking as much.
Yeah. So, but yes, it is possible, and we've seen it repeatedly. It is possible to take a battery and increase its not only its life cycles, how long it will last, but actually get more energy out of it per cycle than even the manufacturer had originally rated it for. So yes, absolutely happens. And just so the listeners understand, this is kind of like natural medicine, where we say that all diseases are curable, but not all patients are curable, and so that's true of batteries too. There, if I pick up 10 batteries from a recycler, I don't know whether or not I'll be able to rejuvenate all of them. I suspect I'll be able to rejuvenate all of them until I can run a series of tests on them, and those tests will tell me which ones are going to be easy to rejuvenate, which ones might be able to be rejuvenated if I had the time and patience, and which ones I shouldn't bother with. And so, again, all of these processes I talk about in depth in my training lectures, the ones especially called battery rejuvenation.
Cool. So now you were. Did you want to continue discussing some of the Bedini stuff and the battery rejuvenation? This is sort of your show, so.
Well, people have. People wonder, whether or not the chargers that we sell now operate on the same methodologies as, the Bedini machines that, can be set up to basically run themselves.
I'm happy you're going to bring that up because that's a question I've had as well.
Yeah, that's a typical question, and I think the simplest answer is at this point, no. The plug-in chargers sold by Tesla Chargers and built by John's company are not designed to produce more energy than they run on. Okay, so it's designed as a standard battery charger that takes energy from the wall plug and but gets it into the battery in a very, very efficient way, and that can be easily determined because during the charging process the battery does not warm up almost at all, and there's almost no off-gassing of hydrogen and oxygen during the entire charging process. There may be a little bit at the end, but those
So if someone buys one of these battery chargers, what this battery charger is going to do is it's not just the effect of what the normal Bedini motor would do to a battery, but it'll also charge it to its regular or exceed its regular capacity.
Well, again, those are exactly the types of claims we don't want to make. What we will say is that a standard charger may take about 35 to 40% of the electricity out of the wall and get it into the chemistry for the next discharge, whereas our chargers can get way better than twice that. In other words, we say that the charge efficiency of the system is about 90 to 95%. In other words, and that can be seen because the battery doesn't warm up like a resistor, and it doesn't off-gas like just an electrolysis cell. In other words, when we buy electricity and put it into the battery, it gets into the chemistry. It gets into the chemical changes which actually equate to being the charge. And therefore, the electricity that we purchased actually becomes available on the next discharge when we need the battery to do what it's doing. So that keeps the cost of running the battery system low, okay? So if you're running, especially if you're running big battery systems, that actual energy cost of running the chargers can be quite high, like in forklifts and other things like that, and ours runs a lot lower. So that's a huge savings that we do claim. You can definitely save money that way. The second way you can save money is that you're just not going to be replacing the battery as soon as you would if you used a standard charger. And that is actually a much larger savings. So, for instance, if I've got a golf cart battery system and I can actually get the full 5,000 cycles out of that battery, and I'm charging and discharging it once a day, that means that the battery will last 15 years. Okay? So if I don't have to replace that battery for 15 years, then I've just saved a lot of money. I've just saved a huge amount of money. And,
so if you were to take this, I drive for a living, so I need to replace my battery every 3 to 6 years, approximately.
Mm-hmm.
If I were to take my battery out and say just with the Bedini motor, I would take my battery out of my vehicle, and for the weekend, I used it to charge up my battery to, say, 8 hours. I would charge it for 8 hours with the Bedini motor. Then I would take a regular charger to charge it back up, but I would have to, the word on the street is that you've got to discharge the charged battery first before you apply the Bedini charge to it. Would I be able to take my battery that isn't able to now start my vehicle in the wintertime and have it then start working again, so I can at least get to the spring or summer, and then apply it again, and then have it, within a few of these treatments, be like new again?
No. And thanks for bringing that up.
Thank you.
That process would not work for you at all. Okay, and it's we have a charger that can do what you want, and that's the smallest charger for the 12-volt batteries at Tesla chargers. It's called the 2A12. It's just a 2-amp charger. It's like a trickle charger to most people, but it's capable of performing the magic trick of what's called topping the chemistry. And you'd be much better off just buying a 2A12 and leaving it in your garage, and maybe once a month putting it on overnight or over a weekend and letting the 2A12 bring your battery up to a maximum charge.
So I wouldn't even have to discharge the battery prior to doing that?
No, you don't have to do that. And what you want to do is, to make sure that the battery remains operational. The best thing to do for a battery is to charge it to the top of its chemistry each and every time it's been discharged. And but a lot of situations just don't allow that to happen. That's the situation where you will get the longest life out of the battery. But if you can top the chemistry periodically, that's second best. And so
I want to do this as like a proactive thing. I don't want to wait until my battery starts screwing up. Correct.
And you want to be proactive because by doing so, you keep the battery in. In other words, you operate on the battery when it has only minor damage, and then you can correct that easily, rather than waiting until it has major damage, and then it's harder to fix. So even a 2A12 can push a car start battery to the top. When the green light comes on a 2A12, the voltage of the battery has risen to 15.5 or 15.6. And under normal circumstances, almost every other charger out there will not even attempt and cannot possibly bring the battery to that voltage. And that is the problem. When the battery is being charged, almost all of the sulfation will come out of the plates at voltages below about 14.4, and that's pretty much where standard chargers stop. Okay, they have voltage limiters in the thing, and they will not allow the battery voltage to rise above that level. And what they don't want you to know is that even if you leave the charger on the battery at that voltage and just hammer away at it for another month and a half, there are sulfate ions in the plates that will not resolve and will not go back in the electrolyte. In other words, because it's not about pushing more current into the battery at that point. Because those particular sulfate ions simply require higher voltage to move them. And so the part of the trick to rejuvenation is to have equipment that will allow the voltage to rise on the charger and allow it to rise safely, but allow it to rise in a way that the battery itself is determining what that voltage is, not the charger. And this is very important. Almost all standard chargers limit the upper voltage, and that's how they know when the battery will fail. Because if they know they can leave, 0.5 or down to 0.3% of the sulfate ions in the plates at the end of each charge, then they pretty much know. In other words, if they can leave 0.5% in there at the end of each charge, they know that the battery won't go 100. It'll go 100 cycles, at which point 50% of the sulfate is in the plates, and you can't get it out.
Can I ask you to just pause for 1 second? I'm very sorry to do this.
No problem.
It was a bit of discussion that we had before, and Frank has posted a link to the charger, but he's posted the R Charge website. Does that website still have supplies available to them to distribute?
No. R Charge is all but shut down. I'm pretty sure that's even if the the website's still there.
Okay. Well, I just wanted the listeners to know that, don't waste your time going there. And can you mention the name again for where people can get this charger?
Yeah, I can just put that in the chat here.
Okay. Someone wrote eBay. So it's TeslaChargers.com. TeslaChargers.com.
Yeah.
And I'm just saying that for people who can't see this and will be, we are actually, this show time travels. Did you know that?
Well, that's very exciting, and I'm sure we can get into that later.
Well, people in the future will be listening to the show. So
it's hard to get the people in the past to hear it, but anyway, at least we can travel in the direction. Good.
Yeah. So I'm sorry I cut you off there. Sorry.
No problem. Yeah, we want people to know where they can get these things, and
exactly.
So yeah, just go to the products page. We have a number of products pages there, including and also there are links on that site to the trainings about batteries and about battery rejuvenation. We want people to know these things, so we're not keeping it a secret. A lot of this was developed during a funded period where I would say there's probably over $1 million of R&D in the development of all these things, and John is basically letting us train people as much as possible.
That's awesome.
Yeah, because we really want to we want people to know how to do this. We want people to recognize, one, that it can be done. And the other thing I want to mention here is that there are other companies out there. If you just kind of do a Google search on battery rejuvenation, there are other companies that have other methods.
I was actually going to bring that up in the later section of the show, but I deliver everything, and batteries is one of the things I deliver. And I've asked them about their rejuvenators because of, when I had done the Bedini motor, I said, you could probably go and buy one of these motors, and it would you guys wouldn't have to recycle your batteries for the money that you'd make, and instead you could reuse them and sell them as a used battery at basically, new. And he said, no, we've already got something. We open up the battery, we throw a chemical in, and it sets a specific frequency to the battery to desulfate them.
Mm-hmm. Yeah.
So.
And so, in other words, this is something that many people have looked for a solution for, and we're not here to denigrate other people's efforts, but I did want to say that basically our system uses only water and electricity to create a complete rejuvenation. And so we do not change the chemistry of the battery in any way. We consider that the chemistry of the battery is already perfect and does not need to be changed. Yeah. And we also don't think that the sulfate in the plates is the problem, okay? It's the condition, for sure, but it's not a problem, and we don't want to get rid of this sulfate, because that sulfate is simply in the wrong place. It's not bad. It's just been left there because of what we call chronic incomplete charging. And so all we have to do is create the conditions which undo the chronic incomplete charging by allowing the battery to be topped off by a charger that is capable of finishing the chemistry, and then do it in such a way that we can root out these deeper layers of the sulfation. And I go deep into this in the battery rejuvenation training talk. All the little things, all the little sneaky little tricks that you have to go through. And you want to do them in a sequence because you may not run into all of them. So you want to, just keep kind of going back down through a list because these things kind of happen in a sequence. And so you may have to go through, 2 points on the list, and the battery will pop back. But you may have to go to the step 3. You may have to go to step 4, and so on. But you don't want to just jump to step 4 because that won't help battery that can be fixed by just doing step 1. So there's
sorry, it's just about the time where we let callers call in, so we'll have a few chats with people, and then at 6 o'clock my time, which is in 15 minutes from now, we'll cut to break, and then when we come back, I would like to ask you something that I've been wanting to ask you guys for a long time, and that is the basis of using supercapacitors and how the Bedini motor will affect it in possibly increasing a supercapacitor's capacity. So, and sorry, it's 9 minutes till we go to break. So I guess I still haven't understood this time thing. So, so if we can put that question on hold until after the break, I would like to welcome Frank. He's the guy that I told you the other day that helped me get my Bedini motor working. Frank, would you have a question?
Yes, that I do. Hey, Peter, how you doing?
Pretty good, Frank. Thanks for joining.
Well, thank you. I'm happy to have you here so I can maybe get a little answer on a couple things. I built a couple of the Bedini motors, and I absolutely can confirm I've changed batteries outright, and it's amazing how much more they run, have power, the works. It's a great thing. And I just checked out your site that you had there. Are you going to have a kit for the 10-coiler?
No. Those were all arranged by Rick on a license deal from John. And then he never paid John any licensing fees. And there were, I don't want to get into a lot of the politics between John and Rick.
Right.
But, it didn't end well. And
could I ask another question then? Is it possible that people could buy plans to build the 10-coiler, so it has all the dimensions, everything, and maybe sign an NDA along with it in order to obtain it?
Perhaps, but that isn't a major point of interest to John. These things are, the original 10-coiler is something that John and I built. You've probably seen hundreds of pictures of it on the internet.
Yeah.
And that unit, as a prototype, with the clear plastic and everything else, that thing cost a couple $1,000s in parts, and took us the better part of 2 weeks to build.
So we're actually trying to get a machining. Sorry, go ahead.
Well, I'm just saying that there's nothing particularly amazing about that configuration. Okay, it was along a line of a series of tests for controlling multiple coils from a single trigger and so on. It's actually and it was able to charge those very, very large cell phone tower batteries that you've seen the pictures of there. We could push a 24 volt 1600 amp hour system to boiling at 30 over 30 volts in a little over 24 hours with a 10 amp input, which of course is insane. The numbers don't add up, but it would do that. And
I do know a lot of people that would be interested in being able to build it, and I've discussed with you. We're trying to sort of get a machine shop together, and people are interested in this stuff. They, John, you and Tom Bearden, you guys have all inspired so many of people from my generation and later and before to start learning how to do this stuff. And, some people aren't good at building things. They just want to have the supplies and maybe they can assemble it, So one thing based on that motor that I was really curious about, and that was, you and I had the chat, and I had that vision, that mental orgasm. And when I built my coil, when I saw the 10 coiler, I noticed that it was very large and filled the coil. So what I was wondering when I had connected mine, it didn't work. It ran very, very slow. So it was 3,000 turns it took to approximately fill that coil with having like a 3/16 rim off of it. Mm-hmm. Would that have? Would you guys have possibly used several multi-tapped coils for that?
Yeah, the original 10 coiler had 4 strands of number 20 wire on each of at about 150-foot lengths, and those were twisted strands. That was the first machine that had twisted strands.
Awesome.
And so yeah, but each of those machines represents a series of tests. And that's what I want the listeners to understand, that there's nothing magic about any of those particular configurations. I know Rick, moved forward and built a lot of 10 coil machines and sold kits and all these kinds of things. But that machine was not designed to produce a lot of mechanical energy. It was designed to, produce a very significant battery charging benefit, and it did that. And
so the more coils you put in it, you will not gain any more mechanical energy?
Well, you can again, and see, this is why people should be, starting, by building these machines, building the, buying the, Bedini SG handbooks, which lay everything out in extremely, fine detail, especially the intermediate book for those more advanced builders. We talk about, making sure that every single transistor is switching at exactly the same time, so that each one of these impulses are additive and they aren't working against each other when one transistor turns 3 microseconds before the next one does, and so on. There's an awful lot to know in these things, and especially when you get
you need to have the coils and the magnets perfectly aligned then.
Absolutely. Yeah, everything has to be aligned, and each of the transistors has to be electrically matched. The intermediate book actually shows you how to build a test apparatus so that you can use matched transistors. So I mean, there's the more complex. It goes like this. If you want to understand how an internal combustion engine works, it's a good idea to take apart a lawnmower. A single cylinder.
Yeah, exactly.
Thing. But the point is that making a big lawnmower engine
1 minute till break
to run your car. That's not how to scale it up. And this is the problem that we get into, is that the 10 coiler was designed. The basic bicycle wheel with, many magnets and one coil at the bottom. That's the fundamental unit, okay? We
got 30 seconds till break, by the way.
The 10 coiler was designed to, show what happens if you maximize that arrangement, what other things you run into. But again, I don't recommend people run out and try and build these things.
Okay. All right. So we will be back with Peter Lindemann, and we'll take Frank back, and he just sparked on a bunch of extra questions. And
they said we could not do it. They said it wasn't possible, but we did it. We created a free radio station to bring the people together and spread an alternative message from the mainstream. They tried to silence us. They tried to hack us. But we carried on. You cannot silence the truth. You cannot enslave freedom. You cannot stop a good idea. You cannot stop Dark City Radio. The crew is now bigger and stronger than ever before. We will not be kept off the airwaves. We will continue. This is not our radio. This is your radio. This is Dark City Radio.
This is your Dark City. This is your Dark City.
This is your Dark City.
This is your Dark City. This is your Dark City.
This is your Dark City Radio.
Crashing down and there's nobody else around to talk to, so I cry myself to sleep. Dreaming of pure happiness, I wake up in my loneliness. If only things were like they used to be. Live my life my own way, both bad and good from yesterday are making me the man I'm gonna be. So I keep shining on, cause I will not be proven wrong. Bide your time and baby you will see. Cloudy skies are coming, but the silver lining makes it worthwhile. If you're in the darkest tunnel, run through till you see the light. And now that you are coming strong, there's no need to pretend, cause it'll all be alright. I live inside my head because nobody understands the dream that makes me do the things I do. Put down at every turn, just getting by on what I earn. No guarantees this plan will even work. Live my life day to day, getting betrayed is the price I pay for overtaking people I once chased. So I'll keep fighting on, not being held back anymore. I'm closer than I've ever been before. So I say cloudy skies are coming, but the silver lining makes it worthwhile. If I'm in the darkest tunnel, run through till I see the light. Now that I am coming strong, there's no need to pretend, cause it'll all be alright in the end. And I know that I'm hurting, and there's nothing you can do. And I know I've been searching for a reason to be true. Cloudy skies are coming, but the silver lining makes it worthwhile. If you're in the darkest tunnel, run through till you see the light. Oh, now that I am going strong, there's no need to pretend, cause it'll all be alright in the end. It'll all be alright in the end. It'll all be alright in the
Well, that's weird. Okay, hi everyone.
Sorry.
Oh, it's okay. Hi, everyone. Welcome back to Inventing a Free World with your host, Matt McMahon, and our guest, Peter Lindemann. And we've covered some battery rejuvenation and the chemistry within it. If you're just listening now, if severe feedback on okay. So if you are on the station and you would like to come in to ask questions in 45 minutes. Remember to push mute as soon as you click these instructions I'm about to give you, so that way it doesn't interfere with the call. So what you do is you go down to the bottom right-hand corner of Dark City Radio Show.com, and you click the Skype button. And as soon as it goes to call in, press mute and turn off your browser, so that way it's not giving feedback for when you do call in to ask questions. So, Peter, I'd like to bring Frank back right away because I sort of cut him off there, unless you wanted to say something prior to that.
No, I think, we were kind of on a roll at the end of last hour, and let's get back in it.
All right, sounds good. All right, Frank, come on back.
All right, I'm here. Okay, now that I've been listening to you about the 10 coilers, and you're saying you wouldn't recommend someone just going out and doing that because the way you guys designed and everything, what would you recommend? I mean, are you coming up with something else, the next generation, or?
Well, here's the thing. The machine was never designed as a replacement for a strong electric motor. John Bedini has always referred to these things as he calls it an energizer, and probably a more specifically correct term would be a self-rotating energizer. Okay, because when he started these experiments, as it was explained in the first Bedini SG book, which can be gotten at bedinisg.com, he started with a more complex design that had an electric motor turning a flywheel, turning what he called an energizer, which was a variable reluctance generator of sorts, a low drag generator that would then feed back energy. It would charge a capacitor and then feed back energy into a battery and the drive motor and keep itself running and keep the battery charged. Later on, he found out by just switching energy to the Energizer device, he could eliminate both the flywheel and the switching mechanism and the electric motor, and that just left him with a self-rotating Energizer, which is where we got to, and that's what we have left of the system now. But it was never designed to produce a lot of mechanical energy, just enough to turn it so that it created this switching event. And so this is the first thing that people misunderstand. Because it's turning, they think of it as an electric motor, and it's really it doesn't produce a lot of mechanical energy. It produces plenty of mechanical energy to keep itself turning, and as long as it's creating the switching process, which is what's charging the batteries. So
if you were to take a one coil Bedini motor and compare it to a 10 coil Bedini motor, there is more mechanical energy with a 10. Is there not?
Well, there may not be. There may be more, but there isn't going to be more in relationship to the amount of electricity that you're flowing through the machine. In other words, the percentage of mechanical energy production, in relationship to the amount of electricity moving through the system, may not be higher.
Okay.
And the situation where we have the coils facing the outside of a large diameter wheel using ceramic magnets was the best that we ever saw. It was about 28% on a dynamometer. But if the batteries are, if the back battery is charging faster than the front battery, or as John showed at the last conference, the situation where he showed what was called the machine running in generator mode, where both the front and the back battery were charging while the thing was running, then we don't care too much about whether it was producing mechanical energy because it's running and both batteries are charging. So what? So it's important to keep all of these things in perspective and understand what the point of the machine is. Yeah.
All right. So a lot of people sort of want to. They're hoping to get this 10 coiler or build one, and there's a lot of people trying to get this done. And their hopes is that they can attach a generator to it and get a little bit of free power.
Right.
So go ahead.
Well, I'm saying that is that's the wrong way to think about it. And I realize that a lot of people are thinking about it that way. And that's one of the reasons why we've put out the books that we have. If you want to build a 10-coil machine, you can, get the Bedini SG, manual. And it tells you everything you need to do to build a 1-coil machine. Well, put 9 more coils on it, and you've got a 10-coiler. So, it's not that complicated. But what we're trying to show you is the building blocks, the science. The last book, the advanced handbook, is going to show all of the details of how to get the back battery to charge faster than the front battery, and the thing will basically run and produce a surplus of electricity. Okay. So anytime somebody's tried to build something large, that'll run your house or something like that, they've gotten pushback from economic forces that want us to buy gasoline. But they haven't really. There's been no real pushback in us just teaching you the science and showing you how to build a machine that, right now, the Bedini SG handbooks are the first legitimate and only manual in print that actually shows you how to build a machine that runs and gives you more energy back than it's running on.
And how much does that cost, by the way?
$27. It's crazy cheap, and it's extremely detailed. It shows everything you need. Okay. It goes right down to hot links to the parts you need to buy. So, it's an absolute. When we say it's the complete, beginner's manual, there isn't anything you need to know except that. If you're willing and able to follow directions and look at the pictures and make your thing look like the picture, then you can build a working model.
All right. Did Frank, did that answer your question? And did you have more?
Yeah, that actually pretty much answers my question. Unfortunately, I gotta take off here in a little bit. But thank you. I appreciate the insight.
Yeah, we would love to just do something that's more straightforward and just sell you a box the size of an ice chest that you just plug your whole house into and run it with no fuel. The problem with that is that if you've got it, then everybody else has got it, and there's a whole lot of people that our government still thinks are enemies, that they don't want certain people on the planet to have that. Because it would change the balance of power, at the political level, and that's just the world we're living in, and there's nothing we can do about that. And so these things are not about to hit the market. They're just, it's not going to happen, and so it's important that people stay realistic about that, and and not get all freaked out, that me and John are the ones that are holding it all back. That's not what's going on.
Yeah, that is actually something I've encountered, and I explain to the people that I encounter that feel this way. They there's some people that just don't believe it because it's probably because of the people on YouTube saying free energy, and then they put the Bedini motor. And I often tell them, put yourself in their shoes. Do you think that if you came up with free energy, that you would be allowed to share it freely? I think not.
Yeah, it's just, we live in a complex world. And, when I started getting into this in the 1970s, nobody would tell anybody anything. And in fact, you needed to travel to some other city. There were only 10 cities in the United States where you could even do a patent search. The fact that the internet has made a staggering amount of information available. So one of the things that's used, and there's just a lot of people out there who believe that closed system thermodynamics, is the end all of science, and that's as far as they've been interested in learning, and therefore,
well, they already know it all. Why do they need to learn any more?
But the thing is that, I think in some ways we're all sort of like that. Whether we may not be that way around science, but we may be that way around diet or religion or, race.
Yeah.
Or something where humans are like this, okay? They don't like to have to rethink, their entire world model, on a daily basis, and I don't hold that against people.
No, well, we shouldn't. We should only help.
Yeah. So, it's a complicated situation, but what we've found is that as long as we stay pretty much apolitical, in other words, we're not trying to make somebody bad or wrong. We're just saying, look, here's this very interesting science where you can use a little energy and you can get some of it back, and you can get, also a transformation into another form. So we put electricity into the machine, and the machine produces both mechanical energy and more electricity back out. And when we measure all these things very carefully, the complete amount of electricity that we can get back by charging a battery in particular, and when we add that to the amount of mechanical energy, the numbers, when done very carefully, the numbers say we are actually producing more energy than we're running on, and that's what John has been saying all along. And
we have a written question. How much load can the Bedini work with while charging a battery with energy? Up against, as much, within its range, okay? This is one of the reasons why many of the machines are shown, where the bicycle wheel is running a fan, for instance, okay? Running a big, deep-cut fan like that takes some juice and moves a lot of air, and it can do that while charging the battery. Okay, doesn't change its electrical efficiency at all, and that's one of the demonstrations that we've used. But you can also put another slave type of coil where the magnets are moving past another coil that's not being energized at any time, and generate electricity on that other coil, and take the mechanical energy off that way as well. And I've actually done that in a very similar way, where I took a 112 AC motor, and it was a really low geared motor. I collect whatever I can get that's based on technology. So I tried taking the output of the Bedini circuit and attaching different motors to it, and I only got one to work. The stepper motor didn't work, a regular AC motor didn't work, but this one, it worked. And it moved very slow, but I could not hold on to that geared motor with, it was probably making a revolution every 5 minutes. But, if you consider that if I can't hold this, you can lift a very big weight and then use that mechanical energy.
Yeah, that's, you were getting a pretty large mechanical advantage. But like I said, you could run a pump. In other words, if you had a homestead or something, you could use a Bedini type motor running from solar panels that would charge batteries as well as run a water pump and to pump water up from your well up to a tank or something like that. So I mean, there are very simple and practical things that can be done. There's enough mechanical energy there to do a reasonable amount of work, as long as you don't overload it. You know, we're not going to ask our lawnmower engine to do the quarter mile in 3.5 seconds or anything. So as long as you're being reasonable about it. See, people because there's unknowns in this thing, people kind of glaze over and they kind of lose their scientific perspective on this, and they just think that there's some sort of magic wand where all of a sudden you can just wave your magic wand over this and all kinds of unreasonable things should be able to be done, and of course they can't. So we're trying to get people to look seriously at this science and recognize what it can do and what it can't do, and and take what it actually can do, and help us work with it. That's really kind of what we're doing. So
the more discoveries happen that way, and that's one of the things that I appreciate that John's open sourced his stuff, because it's allowed people for me to take whatever motor I can get to see if something would work. It allowed me to learn something. So, Alien, he's from Earth, by the way. He has a question. Alien, would you like to ask your question?
Yeah, I'm just wondering, with your battery charging technique, have you ever done anything with capacitors in the same regards?
That's exactly what I was going to ask afterwards.
Great. Well, let's get into that a little bit.
Okay, if I could just mention something that I've bought, so that way maybe you already know those supercapacitors. I bought 2.5 volt, 2600 farad supercapacitors, and I think I bought 30 of them. And I was going to make a 48 volt battery, which would be more than 48 volts, but I would make sure that it wouldn't exceed that. Would the Bedini motor make my batteries exceed that 2600 farads?
Capacitor, not battery, remember.
Sorry, capacitor, yes.
Yeah, see, no, it wouldn't.
Okay, I like how you say no, by the way.
Yeah. Well, I'm trying to understand the question without...
Okay, maybe I should just say it again, so that way I'm not unclear on.
Yeah, you said it really clearly, and the answer is still going to be no. And again, what's going on in a battery, okay, which isn't going to be going on in a capacitor, and I can talk about this because I do know this, okay. What gives you capacity in the battery is the mating surface, the surface area of the plates in relationship to the electrolyte. Okay, and if and here's the trick, and why the Bedini, why our charging systems can increase the capacity of a battery beyond what it is expected to do, and that has to do with applying the electricity in very, very small increments using low currents, okay? Because the current, the rate of current applied to the battery seems to also relate to the size of the particle which is deposited on the plate during the charge process. So the slower the charge, and the higher the voltage you charge at with limited current, you can produce very, very small lead oxide particles. Now, if this will give you a very, very large surface area. Okay, in other words, if I take 1 cubic inch of material, okay, let's say it's aluminum or something, okay,
Yeah.
I used to make systems that made colloidal silver, so I would use the silver, as the example, for instance. So if we were trying to make colloidal silver, which obviously is a lot of little particles of silver in water, and if we look at it as if I've got 1 cubic inch of pure silver, okay, and I drop that into a glass, I've got 1 particle, and it has 6 square inches of surface area, okay? That's very simple to see in your mind, okay? Now, if I take that 1 cubic inch of silver and I simply divide it into chunks that are 1/10 of a cubic inch each, okay? So in other words, I just take each inch and I divide it into 10, and in all 3 dimensions, okay? And now what I get is I get 10 times 10 times 10, or 1,000 chunks of silver. And that 1,000 chunks of silver, each one of those chunks has 0.006 square inches of surface area. So 1,000 times that gives me not 6 square inches, but 60 square inches.
Okay.
I've increased the surface area, okay, and but I haven't increased the amount of silver, okay. But I've increased the surface area, the mating surface between the water, and as I continue to make the particles smaller and smaller and smaller and smaller and smaller, the surface area rises. And so as we charge the battery with these microcurrents, with a high degree of electrostatic charge associated with them, the surface area on the plates goes up, and this is exactly what Frank and others have seen. That my gosh, these batteries just give it and give it and give it, and that's the reason. There's a chemical reason why that happens, and it's about surface area. Okay. So that's exactly what you can't get to happen in a battery. I mean, in a capacitor, because the capacitor isn't storing anything.
Okay.
It's just the amount of surface area in the capacitor is exactly what they manufactured it as when they made it, and that's the end of it.
Okay.
So,
all right.
That process is not available.
So Alien asks, okay, so can capacitors be regenerated like batteries?
Well, there's another thing that can happen with a capacitor, which is a different phenomena altogether, and I talk about this. Actually, there's a whole chapter on this in the second Bedini SG manual. It's called the the Complete Intermediate Handbook. And that is that when these electrostatic style charges are coming back out of the machine, and you use them to charge a capacitor, what tends to happen is that the electrolyte, or the dielectric material, which is usually a type of plastic in an electrolytic capacitor,
polyethylene or something.
There's a number of different ones that are used. Okay?
Yeah.
When you use capacitors that are susceptible to this process, the dielectric material tends to polarize, and that helps the capacitor hold a charge. Okay, so that when you discharge that capacitor into the battery to charge it, and then disconnect it from the battery again, what happens is the voltage in that capacitor jumps back up towards where it had been before without you actually putting anything else in it.
Oh, that's interesting. But does the farads go back as well? Well,
the number of in other words, its farad rating isn't changing. What's happening is that there is we call it the temporary electret effect. Okay? In other words, an electret is something that can store an electrostatic bias. And you can get these machines to create that phenomena temporarily in certain types of capacitors. And so this is something that we talk about. Why when you charge a battery directly with the pulses from the machine, you get one efficiency, but if you charge a certain type of capacitor with the output of the machine and then dump that into the battery, you can sometimes get more. And this is the reason. So because this temporary electret effect can add more charge. Because
so is this would you say, even though it's controversial to say, would you say that this the static is coming from the environment around, or is that just some unusual? Like, I know that there's with different polymers, there's you can remove a positive off of one, and then the negative on the other side will naturally bind from the environment, or something similar to that. It's been a while since I looked at that. Is that what's technically happening, or is theorized that's happening?
Well, I think there's multiple theories as to what's going on. My theory doesn't. My personal theory doesn't involve that. I always look for the lowest common denominator. In other words, the simplest answer is usually the closest one to correct. And so there have been very definitive experiments run at universities where they'll take a capacitor, they'll charge it up to full, and then they physically, mechanically take the capacitor apart. Okay, they take the plates away, they take the dielectric away from the plates, and when you look at any of these things, it looks like there's nothing there. Okay, and then you can take the dielectric material and put together a new capacitor using different plates. And when it all goes together, the charge is there. And so the answer, everybody thinks that energy in a capacitor is, electrons sitting on the plates, and that's completely not what it is, okay? It is a stress. It is an electrostatic stress across the dielectric material. That is the actual charge that is being held in the capacitor. And I don't care who believes me, that is what it is. And there's staggering amounts of evidence to support it. And therefore, if you can get that material to hold a temporary bias such that even after you discharge it, it tends to charge itself back up because that bias isn't completely lost on discharge, then the charge is literally just remanufacturing itself because that stress was not completely relieved by the discharge of the energy stored in the capacitor. And exactly why that's possible, I don't know, but and certainly it has very little to do with the idea of the conservation of energy and a lot of other things like that people want to believe, but I don't. Then, if you're willing to just follow the experimental evidence and, not be in a hurry to, jump up and try and make everything you're looking at, fit some set of beliefs that you hold dear. If use
your own observation.
Yeah, if you're just willing to observe what's going on, be honest with the measurements, and deal with the implications of the result, then you can learn something. You can learn something about how nature behaves, which are very exciting when it comes to energy management and these types of machines.
Yes. So you seem to know quite a bit about capacitors. I did have another question based on the capacitors. Is there a way to make a capacitor hold the charge? Because anybody who's, I call it playing, anybody who's played with capacitors, which people should not play with capacitors, they're dangerous. it always discharges it on its own. I sort of see it as the ground sucking that power in, sort of like how it does with lightning. Is there a way to prevent that from happening?
Sure. First of all, it's not the ground sucking the power out. It's what's called effective series resistance. It's the rating ESR, and it is simply an internal leakage, the imperfection of the dielectric phenomena, and this is well understood. Very, very standard electronic theory.
Okay.
Very few.
So they're just imperfect.
It's just an imperfect separator. Right.
Okay.
The types of capacitors that don't discharge very fast are the type where you have the type that Tesla used in a lot of his experiments. If you take two glass jars, one of them slightly smaller diameter than the other, and you put salt water in both jars, and put the smaller jar down in the middle of the bigger jar, and then just drop a chain into each one, you've got you have a situation there where you can charge that up to thousands and thousands of volts and stick a top on it, and it's dangerous to walk up to hundreds of years from now. As long as
it holds the charge.
It holds the charge because the glass isn't gonna leak.
So really, capacitors should be made out of glass then.
Well, I'm just saying that. Well, but that's not practical. And they're
weight-wise, yeah.
Kinds of things. So and they're expensive. So again, we wouldn't have any of these. Your cell phone and your, so many of the devices that we depend on that allow for this astonishing communication mechanism that we're using now. I'm sitting in my basement in Spokane, Washington, talking to myself in a basement room, and you're in Ottawa, Canada, and the radio station somewhere. Where is it?
It's in the UK. Bob actually had a question, so maybe when he wanted to ask a question. So, Bob, come in and let us know where the radio station is located.
The radio station's located on the internet.
Yeah.
It's made up of geostationary satellites and multiple ground stations.
There you go.
I don't know what the question was.
It's a miracle,
Yeah.
And,
well, I'm sitting in a parking lot right now on my cell phone.
There you go. So, but the fact that we can all talk to each other, has to do with the fact that a lot of really smart people figured out, how to make capacitors good enough, transistors good enough and small enough to work well enough that they could be that all of us could afford to own a bunch of them. Okay?
Yeah.
And that became more important economically than making one that never leaked. Okay?
Yeah. Okay.
And and it's so, that application, obviously we're all really, really we've benefited tremendously because the technology was developed in this way. And I publish books and films and stuff on the internet. Okay, we laugh about it. We sell expensive electrons. But literally, I don't have to print anything. I don't have to mail anything. I don't have to do anything, and I can educate people anywhere in the world. Because they can have my product. Somebody in any country of the world can come to our website. Push a few buttons, download our product and be learning from it in 15 minutes. And I think that's
exactly.
Yeah.
So I did have, we discussed something before the show, and because of, I was getting phone calls and people were honking at me while I was driving. I did want to ask you something, and it's on this whole concept of a free world. And, it seems that a lot of the very scientifically minded people see that as, a way to our future. And it does possess much logic because of the lack of oneness and the whole including the world and not being for one and being for all. So I wanted to ask you, we have a like page on Facebook, and we actually just got a website up and running. It's still being worked on, and it's called the stepmovement.org. And today I put in that on the like page on Facebook, I have a dream. These were such powerful words. So I want to know what your dreams are. What do you want out of life? What do you want? How do you want to live? Please share your dreams. So would I know that you're probably as close to any of us as living your dreams, but what do you think of this?
Well, I think it's a great thing that people have to think about. I think the economic forces of the planet would love for us to spend 100% of our time figuring out how to make money so they can collect more taxes, and that leads to pretty empty, miserable lives. I think the most important thing, they want us to believe that science is the final arbiter of reality, and that is complete nonsense. It does help us understand certain things, but it's not going to allow you to quantify, how much your mother loved you.
Exactly.
Your mother's love is not. Has no inertia. It has no gravity response. It can't. It has. It doesn't fit into any. E equals mc squared, and so they want us to believe that it doesn't exist. Okay, that it has nothing to do with how the universe operates. And of course, it's complete nonsense. So, because there isn't a single scientist out there, who can do anything resembling decent science if they weren't loved by their mother. So, because their personality wouldn't function. Okay.
Exactly.
And
if anyone that's listening to this right now, you can go, if you want to share exactly what we're talking about, you can go to the like page, the Step Movement to Worldwide Freedom, and share what your dreams are. Sorry, continue.
Okay. Well, when I look at, all the people who argue against free energy, for instance, there is no such thing. The laws of thermodynamics say it's impossible, and so on. And so what I do is I very politely ask them, well, you believe in physics, you believe in cosmology, you believe in do you believe in the Big Bang theory? Okay, in other words, here's the scientific explanation of why the universe is here. Okay, do you believe in the Big Bang theory? Because if you do, what you believe in is that at some moment just before the Big Bang, there was nothing. Nothing at all. Not an empty space. The empty space wasn't even there. There was nothing. Okay, and then all of a sudden, this explosion started, creating all of these things that we now can see and hear and touch and feel and all this stuff. Okay,
including us.
So if you believe in the Big Bang, then you believe that the universe appeared because energy and mass started manifesting itself for no reason that we know of, in extreme profusion, and nobody was given the bill. Okay, nobody had to pay for it. Okay?
Yeah.
So that means the whole universe is based on free energy.
Well, it is, and that's something that I try to explain to people quite often, and they get mad at me. The fact that gasoline is free, our lights are free, our computers are free. It's just that everything has been stamped with time and money.
Well, the costs of manipulating the materials. All right.
Surviving.
Yeah. Okay. And
so I had another one, which is sort of what you're getting into now. So I wrote on the like page, I have a question for you that may turn into a public project. I'm trying to get people to get involved and to express their passions, read some of our speeches in front of a camera, and hopefully turn this into an international movement where every person does a speech in their own language and they do one in English, and then we can cross-reference so that way people all over the world can hear these passionate words. So the rest of this is, if you do not have to choose a profession based on income or work a job to survive, what would you have done? What profession would you have followed? Money would be no object. You would have to, you would have every single thing you need for a living and to do whatever you want. If you wish to share your need to do what you want, to do what you love, please share on this page. So, what do you think about that?
Well, I think it's a far-reaching idea.
It's unrealistic at this point. I understand that.
Well, I'm not. I don't care. I mean, your mother's love was unrealistic. You were just you were a bedwetter. So that wasn't realistic either. So that's not a.
How did you know that?
You were just a screaming, demanding.
Oh, I'm kidding.
We all were, So the point is that even being reasonable, even being realistic, these should not be criteria for the evaluation of these types of questions about life. Every one of us is, using our mind right now to think about these ideas and to consider them. But our mind, our consciousness isn't, inertial responsive. It has no response to gravity. It has no, dilation of, at the speed of light or anything else. And so our thoughts don't conform to the laws of physics as they've been handed down either. And so if our mother's love and our thoughts and all these things, that's actually more of what I experience on a daily basis than what is defined by science. And though when I do science, like talking about how a battery works or talk about what's going on with the Bedini machine, these things have to be defined in scientific terms because these things are observations of the physical world. That's where science works, okay? But it's not an observation of the mental world, of the emotional world, of the, cosmological world. We have to understand, we have to come to grips with the fact that there are forces in the world that want us to interpret the bulk of our experience and take advantage of us economically when we maladapt, to these influences. And when you see this, when you finally get, that's how I'm willing to be so stupid, then you're starting to wake up. It's like, watching the Matrix movie and you get to take the red pill.
Beautiful movie.
Okay? Unbelievable. I just marveled that it was allowed to be made, because it's so...
Yeah, mine too.
It's
mind-blowing.
analogy to the actual setup that we're in.
It is. It was a really good movie to start waking up people, and I think that movie was definitely one of the beginning was the beginning of all these movements. It really, it blew it right in people's faces without them realizing, and then they had time to sort of reflect on the movie afterwards and go, hey, that's what we live in.
Yeah, copper top, So, our lives have a higher value than our economic interaction would suggest.
Yeah. Would you agree that we sort of, I know that you sort of agree that we're sort of, at the mercy of the economic system. Would you sort of agree that we're sort of used to sort of, our time is money, and we use that money to live and survive, and really it's just all consuming. So the concept that I'm trying to get across to people is that this time, and which is converted to money, is nothing but waste. So we are investing all of our time, 8 hours a day, 13 hours a day in my case, during the week, to then literally either eat it, buy it, and throw it away in 1 to 15 years, or just literally throw it away on something I don't need. Would you agree that it is the system itself is just based on throwing everything away?
Yeah, more and more. When I was a kid in the 50s, it wasn't as bad, but that's
why they made TVs that lasted. When I was, I watched TVs that were made in the 50s. Now they last 10 years max, if you're lucky.
Yeah. Well, everything is designed to wear out quickly now. So the point is that society has real problems, and one of them is the waste of resources. If we weren't, like you said, if we weren't spending all our time trading it for money to buy things that we use once and throw away, so that then we have to go back and do it again. If we could actually buy things and use them, for 15 years, like buy a battery and use it for 15 years without replacing it, then we don't have to go back and work, to buy another one. And if we
you're counteracting the effect.
Yeah, if we could go back and do that with everything that we need and everything that we use, you see, then the cost, the quote cost of living, starts dropping, and our personal need to interact with the economy, to earn money, to trade our time for money, less, and that's the equivalent of freedom. And so the idea is that we want to start defining our freedom as being able to experience a meaningful life without having to pay a lot of our time for that enjoyment.
Mm-hmm.
That or the real, to have contactful, meaningful interactions with others. Okay.
Exactly. So we're getting pretty close to the end of the show. I did want to ask something. As you know, I'm a water fuel researcher, and that's how I got started. And if it's too much of a controversial question, you don't have to answer it. But I know that some of my friends will be listening to this that are into the water fuel stuff, and you and I had discussed that that seminar that you did, or the I forget what it was. It was in 2000 or 2002. You said, where you had mentioned that that basically what Stan Meyer had done with the water fuel cell was he excited the water to the point of a catastrophic breakdown. So I would like to bring that back up and hear, we're all always learning. So is that something that you would sort of wish to discuss?
Yeah, we can talk about that. Okay,
right.
So for those who don't know what Matt is referring to, in a lecture which is titled "The World of Free Energy," which I gave at the KeelyNet conference in June of 2000, there is a citation where I talk a little bit about my current beliefs on the Stan Meyer system at the time, and my read on the patents and other things at the time was that he was using very high frequencies and very high voltages to drop into a water fuel cell that didn't have any electrolyte in it, which meant that it had a relatively high dielectric characteristic in the water. In other words, it was acting more like an insulator than anything else.
No
and he used very short pulses to do this. And my belief at the time was that if you drop a 50,000 volt pulse into one of these things for a very short period of time, the charge will be held there, but then eventually it will break down the dielectric characteristics of the water, and then that charge would actually discharge in the water cell itself and resolve as current, which would break down the water into hydrogen and oxygen. And I had proposed that as the method by which Stan Meyer was getting a lot of gas production for small amounts of electricity. And we're 13 years later now, and why that is a very interesting idea. I think that what Stan Meyer's actually was doing is not that our method, or at least that isn't how the system worked, and that that there are dozens and dozens of websites now out there which explain a completely different method, and I'm more of the minds to believe some of the other theories at this time.
Okay. So for anybody that's listening that has heard him say that, to anybody that is researching, we all have theories on our own understanding of our observations or what we've learned. So usually within time, we continue to try to research and find out more about it, and sometimes our theories do change. So I know it's a pretty tough world out in the the HHO community, and I just wanted to sort of help you because I talked to you the other night, and really that was one of the most amazing conversations I've had in a long, long time. And I wanted the people to know that are listening to the show that Peter is a really good man, and do not judge anybody, including Peter, based on a theory. It is only a theory, and if you believe something differently, then you have every right to believe that thing differently. But don't prosecute someone else for thinking something that you do not.
Well, you can prosecute him, but don't persecute him.
Okay. All right. So we are almost on the show, and Alien did have, we have 1 minute. So, Jado, can you come on for a second? Are we allowed to extend it 5 minutes to, he said no, he's okay. All right, so we got 30 seconds left. Thank you so much for coming to the show today. It's been amazing. There is a bit of an after show usually, so if you wanted to stick around and chit-chat, that would be awesome. And that was Inventing a Free World. Thank you for everybody who listens, and take care. Love you all. Bye-bye.
Thanks, Matt.
Been a pleasure.
In 2012, a group of radio enthusiasts were told they couldn't broadcast without a license. These folk promptly escaped the clutches of a maximum security corporate system to the open source community. Today, still wanted by the state, they broadcast as soldiers of freedom. If you have a problem, if no one else can help, and if you can find them, maybe you can hire the Dark City Radio crew.
Lead-acid batteries, because they're still the workhorse of the world in relationship to large-scale electric power. And an interesting detail is that there are actually more lead-acid batteries on the planet than human beings, so there's over 8 billion lead-acid batteries on the planet. Most of us own, 7 or 8 of them.
I own about 10.
Yeah, they're in our cars. They're all over the place. They're used to start our lawnmowers and all kinds of things. They're everywhere. So, and of course we want to keep lead out of the landfills, and we want to make sure that this material is, handled properly environmentally. And so we have focused primarily on the lead-acid battery as the one place, if we really understand the lead-acid battery and can use it properly and keep people from needing to buy new ones and keep them from wanting to throw them away, then we feel like we've made a significant contribution to a cleaner, greener world. So we're reusing and lengthening the useful life of, the batteries. So, so with that in mind, I can talk to you about the lead-acid battery in particular, and just so that everybody knows that there are variations, on these themes that relate to the various other chemistries, but that the information that I'm going to tell you is specific to lead-acid batteries and would have to be modified to directly relate to another type.
Okay.
So now that we're a little oriented here, believe it or not, a lead-acid battery is a fully reversible chemical water fuel cell.
And I'm aware of that.
What I mean by that is, because most people don't know that.
No, they don't.
When you take electricity out of the battery goes through a series of chemical changes whereby it makes a water molecule. And that is a very interesting situation. So when you take electricity out of a lead-acid battery, it's making a water molecule, and it is the production of that water molecule that actually releases the electricity for you to use. And so the discharge process is very straightforward. There's only one significant electrochemical pathway, and that is when you take electricity out, the battery makes water, and that causes two other things to happen. One is that the amount of acid in the battery starts getting watered down in the electrolyte. So we're making the electrical properties of the liquid in there less electrically conductive. And the other thing is that the salt, or in this case the acid, which is sulfuric acid, and its chemical formula is H2SO4, or two hydrogen atoms connected to a sulfate ion, one sulfur atom and 4 oxygen atoms, SO4. So the process takes the hydrogen, combines it with some oxygen on the positive plate of the battery, which is made out of lead oxide, makes that water molecule, and then it's got these sulfate ions that has to happen, that has to go somewhere, and they plate out on both the positive and negative plate. So there's two things that are happening. The electrolyte is getting more dilute, and the sulfate material is being plated out on both the positive and the negative plate of the battery. And that's the normal discharge process, and that's the only thing that can happen. So discharge is never a problem. You can ask the battery to discharge, and that's what happens, okay? So all the problems associated with battery degradation and the ability of the battery to continue to do this process has to do with the efficiency and the effectiveness of the charging process. Because when you put the electricity back into the battery, the first thing you have to do is you have to break up those water molecules, and that's generally called electrolysis. So when you put electricity in, it breaks the water into hydrogen and oxygen. And everybody is familiar with that process who has any chemical background. It's a very basic process.
Yeah.
However, if that's all that happens, that doesn't charge the battery. In other words, if I just put electricity into water and it makes hydrogen and oxygen, and the hydrogen and oxygen just bubble out, then I've produced hydrogen and oxygen gas, but I certainly haven't done anything else. And so it is possible to put electricity back into the battery in such a way that does not charge the battery. Now, this is something that most people haven't, who haven't looked into the situation, don't understand. And this gets into, okay, so we're looking at how efficiently the battery is charging. In other words, I'm buying electricity from the wall to charge this battery back, and how much of that electricity am I actually getting back into the chemical changes that I need to have happen in there so that I can pull the electricity out later. And a typical battery charger that you buy for these things is really scary as far as how efficient it is. It's about 35% efficient. In other words,
so it means that there's a 70% waste in energy when you're charging.
Well, let's just say a 70%. Yeah, you can use the word waste. I would just say yes. And so when we started looking, when John Bedini and I started looking at this, we just said, well, there's definitely room for improvement here. And so we started looking very carefully at what needed to happen. And what we found is that what needs to happen is that when the electricity is applied to the battery, the electricity has to do two things, not just one. If it just does one thing, it creates electrolysis and the gases bubble off.
Okay.
Okay. But if it does the right thing, if it does what it takes to charge the battery, then a slightly longer, complex set of activities happens, and that is that the electricity is added to the battery, the water molecule is broken into hydrogen and oxygen, and it's the energy in that reaction is then characterized in such a way electrically that the hydrogen, instead of forming hydrogen gas and bubbling out, creates hydrogen plus charge ions which stay in solution, and they go and grab sulfate ions off the plates and stay in solution in the water. Whereas the oxygen, which becomes liberated, goes to the positive plate of the battery and reforms the lead oxide and plates itself back on the positive plate. Now, if all of those things don't happen, then you haven't charged the battery. And so you can see that, well, heck, that's a lot of stuff that's got to happen.
Yeah.
But if you can get all that stuff to happen, then you've actually charged the battery. So we started looking, John, that amount of energy, whatever it is, metered at 30, apparently looking like 35% of what you're taking out of the front battery. And you just put that on you just put that on a second battery to charge it.
Mm-hmm.
Instead of trying to put it on a capacitor or burn it in a light bulb or do something else with it. If you just shunt it off to a second battery, a remarkable transformation happens whereby the back battery charges up to maybe 90 to 95% of what the front battery ran down from, which makes the energy look a lot more interesting coming out of this thing. And when I came to work for him in 2004, this is pretty much, he'd been doing these types of things and trying to convince people that it was interesting and, getting a lot of pushback from electrical engineers who just wouldn't, who'd measure the output directly and say, there's not enough here to push a fly up the wall, and you aren't going to get us to look at it any further. And so we started, and so we started doing, some very systematic experiments where we started looking at this and started looking at what was going on in the batteries and started really studying about what goes on in the battery during the charge and during the discharge and the whole all the chemical reactions that were going on, how the battery was changing under the influence of this energy coming back out of the machine.
Now, would you be willing to explain some of that? Is that proprietary knowledge at this point, or are you able to share that information?
Well, I mean, we have shared quite a bit of it in lectures and in training situations. We have a series of lectures that I've given at conferences. One of them is called Battery Secrets, where I talk about what goes on in the battery, and then another one that I gave recently at a conference this summer called Battery Rejuvenation, where we go rather deeply into all of these things, but it's kind of an arcane subject, and I don't want to, either bore or, your audience or talk over them from a technical point of view, but I can certainly go over, the fundamentals of it.
Well, see, the way how this sort of works is that if people who are very advanced thinkers or, that are well involved in their technology, they usually have a hard time explaining that to the public because not everybody understands it. So my job is sort of to ask you the questions where when you say something, if I sort of think, or if someone writes in the message board, what did you mean? We'll ask you to elaborate on that a little bit more, or I'll ask a specific question so that way it is more understandable.
Sure.
Personally, I'm very interested to know what is happening to the chemicals within the battery. I have my own theories. I haven't seen your what do you call it, conferences, but I would definitely like to know, and I'm sure there are people listening to the show. I know that there's friends of mine that are on here that have experimented with Bedini technology. So, I would really like to hear that.
Great. I can go through it. I can. So basically, every battery chemistry is different, but we focus primarily.
Like individually? Do you mean individually or the different types?
No, I mean the different chemistries. In other words, a nickel-cadmium battery is chemically different a nickel-metal hydride battery or a lithium battery or a lead-acid battery and so on. So we have focused primarily on...
Hi, everyone. This is your host, Matt McMahon, in Inventing a Free World. Our guest today is Peter Lindemann, and so I guess Aaron, I can't pronounce his name. Murakami. He saw what we were doing with the show, and he's pretty well connected with a lot of what some people would consider the really high up there guys that are doing alternative energy. And so Aaron is going to be trying to help us get a lot of really smart, amazing guys information to the show, which also allows people to get involved and ask the questions that they never got to ask another inventor. So, sorry. Sorry, I'm bombing here a little bit. Oh my God, there's. All right, so this week we have Peter Lindemann, and he's done some work on the desulfating of batteries, and I'm sure if I've made any rejuvenating batteries. So I was going to say a speech, but unfortunately I am on my Bluetooth and trying to drive to a safe location, so I'll save it for a little bit. If anybody is listening on the website, please go to, but first before you go to it, click the mute button and go down to the bottom right-hand corner and click on the Skype. As soon as you click on it, hit the mute button so that way there's no interference. So I'd like to welcome Peter Lindemann to the show. Hi, Peter. How's it going?
Really well, Matt. Thanks for inviting me on the show.
No problem. I really appreciate you joining. So this battery rejuvenation stuff. What's a lot of people that are involved in the Bedini technology, they know a little bit about that. Is that what this is, or is this something a little bit different?
Well, it grew out of that situation. John started building regenerative motors back in the 1970s, and instead of just taking the energy that you can get back out of a coil when you turn the power off and putting that on a capacitor and trying to use it again, typically in a situation like the motors that he has, the amount of electricity you can get back out of that situation looks like maybe 30 or 35% if you meter it. So it doesn't look that exciting, especially to people. Yeah.
That leads to a really big question that a lot of people have had about like the SSG circuit. A lot of people on YouTube are, they'll put with their video free energy Bedini motor. So what is the consumption, and what is the equivalency of what you're getting out of it? Is there a 30% loss? Is there a 30% gain? And this is just with the regular, little wheel, nothing too advanced.
Right. Well, that's what I was kind of going to get to. If you just meter it with standard meters, in other words, expect everything to be referenced to ground and all the standard electrical engineering protocols, it looks like you can recover maybe about 35% of the electricity. And so the naysayers and the doubters have had a field day with this, and we've never really debated those issues. What John found out early on is if you take John's a master circuit designer and
electronic engineer,
electronic engineer and audio engineer. It's very it's famous, no less than famous in the audio industry. But we had noticed for decades, John had noticed for decades that the little pulses of electricity that were coming out of his machines tended to create this very, very, very efficient charging process. In other words, the battery looked like it was charging way better and way faster than the amount of electricity that we were giving it. And so once we realized what it really took to create a charge, then we went back and looked at what was going on with these pulses that were coming out of his machines. And so, you know, we broke this process down in a number of steps. You know, doing the hard science, and you know, came up with an understanding of what it actually took to not just charge a battery efficiently, but we also started understanding why ordinary battery chargers don't do this particularly well, and that was the fundamental reason why batteries don't last as long as the manufacturer says they should. So, for instance, like a golf cart type of battery, which is a 6-volt, 225 amp hour lead-acid battery, the manufacturer says that these batteries can last 5,000 cycles. And I'm sure you can go to every single golf course, you know, golf cart barn, you know, and the guy maintaining these things is going to say, well, I'm lucky to get, you know, 2 to 3 years out of these batteries, and you know, we're you know, charging and discharging them about, you know, once a day. So once a day for a year is about 360 cycles. So 3 years is, you know, just a little over 1,000 cycles. And by then the battery's shot. Won't charge. They take it out and they can barely get 9 holes, much less, you know, 36. And the battery's lost all its capacity. So even though the battery manufacturer says it can last a lot longer than that, out in the field, it just doesn't. And so John and I started looking at that and saying, okay, what's going on? Why are the batteries not living up to their potential life cycle rating? And so we started looking at making chargers that would solve these issues. First of all, you know, chargers that would, you know, lengthen the life cycle operation. And then that led also to an understanding of what kind of damage was going on in the battery that shortened its life, and then what we needed to do to even a damaged battery to bring it back to the chemical state of what we call a like-new battery. In other words, if I can